Actually, I was not asked to talk about my company and our product line. I was asked to talk about Europe as a key innovator of industrial laser applications. So actually, I'm in laser technology since more than 20 years. Developing but also selling, addressing different markets. I might be a little bit more technical than the title anticipates. Is this direction? Just need to get used to this one here. Ah, okay, good. So I thought, talking about the laser technology in general, laser, applications, markets, where lasers, industrial markets where lasers are being used. I mean, the laser technology is a wide field. I could go on hours and hours. So I try to make it as simple as possible, and I divide the world in, basically 2 or 3 bigger parts. So I'll leave something out, but to give you a general overview, and I'm going to touch on the European part or involvement into lasers or laser development while I go through the different technologies and application. So let's start with the historical development. In this part here, I just divide divide the world, the laser world, into two major platforms: gas lasers and solid-state lasers. 50 years ago, a company was established right after the war, after the laser was invented, spectrophysics. So I was I was lucky to work for these guys in Silicon Valley, but also in Germany for almost 10 years, or more than 10 years basically. And these guys were involved in the beginning of day one in argon ion lasers and going forward even in CO2 lasers. And but that was in those times that was all more or less scientific related. And I have to say, this European companies took over part of those, of these platforms, like this, especially the CO2 lasers, and made it an industrial laser, like Trump, very famous, still is using a lot of CO2 lasers in industrial applications, and others, Asian integrators using CO2 lasers in industrial manufacturing. That's why I'm saying, the life cycle of this platform in lasers is amazingly long. In general, it's amazingly long. And if you think about CO2 lasers, it's around since more than 40 years, definitely. It's because of simplicity of the design, lowest capital cost. Range, and these lasers range from single watts to multi double-digit kilowatts. Can be used for marking, which is very important for traceability and cutting and up to cutting of thick sheet metal, and this is basically in European and maybe a little bit more an Asian play today. And these lasers are still around in the field, and I'm touching on that a little bit later. The second very important platform here is, I want to mention, is excimer laser. Excimer lasers are being used. I mean, excimer lasers were invented in Europe, especially in Germany. There was one startup starting up in the 70s, late 70s, in Göttingen, which later on was taken over by an American laser company, Coherent, which pioneered this technology. And these lasers are still around, creating a lot of cash based in applications like flat panel annealing, where probably 80% of all lasers are being used are based on excimer laser platforms. And more medical and ophthalmology, excimer laser is one of the the laser that's being used the most in this field. And again, that is a dinosaur for laser platforms, but it's still around. It will be still around for quite a while because it's hard to replace. Argon ion lasers is another kind of gas laser technology that's still around, but it's going to be replaced by diode pump solid state lasers and diodes going forward. The second platform, and here simplify this the view on the technology to these two platforms, gas lasers and solid state lasers. The second one is the solid state laser, starting as lamp pumped, maybe also in the 70s already being used in automotive application like welding and going forward, and such application. As gallium arsenide technology matured and laser diodes became available and the power for laser diodes, especially in the 900 nanometer range, increased a lot. That triggered the development of diode pump solid state laser compared to the lamp pump solid state lasers. And these lasers are this technology is being used in a variety of applications, in a variety of different, with a variety of different features, wavelengths, UV range, green, infrared, but also in as pulsed technologies. Ranging from microseconds up to femtoseconds, and that part is going to be more and more interesting for micromaterial processing applications that I'm touching on a little bit later. This development is basically, a European example where a lot of startups started here based on Fraunhofer and university programs. Started here in Europe, in Germany, France, and Austria, Switzerland. Unfortunately, or fortunately, I don't know from which direction I'm talking. Currently, there's a big consolidation going on in this field. These startups getting picked up by American companies like Coherent and Spectrophysics, JDSU, etc. Another interesting laser platform for more, high power application has been developed in an institute in Stuttgart over the last, I would say, 15, 17 years. That is disc laser. Disc lasers are being sold by, for example, Trumpf, used by Trumpf for laser. For a variety of applications, especially cutting and such. But this laser was, that is an example for development that was probably a little bit too slow to market, because in the meantime, the telecom bubble burst, and a number of companies turned their business plan, their telecom business plan, from telecom to photonics, and that's, I'm talking about especially fiber laser platforms that used to be, that were aiming a telecom application, and after the telecom bubble burst, companies like, especially a famous company like IPG, turned the business case around and use this technology to develop high power fiber lasers. And these fiber lasers are really taking over a lot of application, especially in macromaterial processing like cutting and welding, and are going to replace, or already replacing very successfully, CO2 lasers in this field. What could be the next step? The next step is, since the diodes are getting higher, becoming brighter and brighter. You know, the diode performance, the beam performance is improving a lot. So we think a direct diode could substitute not only CO2 lasers but also a part of the fiber laser applications like sheet metal cutting. So I'm going into the main application fields of applications, starting with micromaterial processing. So this area is being, in this area of lasers like nanoseconds, starting from nanoseconds up to femtoseconds, are being used mainly based on direct pumped diode pumped solid state lasers. Some fiber and diode pumped solid state hybrids are being used, coming to the market. The main application segments here, market segments. One of the biggest market segments is semicon. Semicon wafer, processing, dicing, scribing, inspection, the wafer inspection, or LDI, laser direct imaging, is an disruptive application for mechanical or mechanical techniques that are usually used in this field. The supplier for this application are mainly American companies like Coherent and Spectrophysics, JDSU, etc. And some of them, smaller companies, as I mentioned before, in the field of femtosecond or ultra-fast laser, are currently taken up by American larger companies like Coherent and Spectrophysics. Photovoltaic was a big bet the last 10 years, and for using lasers for especially in the thin film area manufacturing. Since photovoltaic is going down, the costs the lasers in this field, laser being used in this field, is slowing down. But automotive is still using pulsed lasers, diode pump solid state lasers especially for ultra fast lasers for example for drilling, and as long as everyone buys, or lot of people buy diesel cars, lasers are the way to optimize diesel fuel consumption in this area. A big driver in the field micromaterial processing is smartphone manufacturing, display manufacturing in general. This is glass processing. Glass processing is very important. It's currently a very fast growing market, especially driven by smartphones and higher resolution displays, etc. And this display, as I said, the technology is there's a lot of this technology is being developed in Europe, especially in the nano and especially in the ultra fast, like femtosecond pulse area. Macromaterial processing, that is a market where we are focusing on with direct photonics. Macromaterial processing, that's where I put all applications like cutting, welding, automotive manufacturing. And cutting, by the way, is in this field the biggest market at all. As it's about 80% of lasers being used in macromaterial processing is in cutting, sheet metal cutting. That's all packaging stuff. It's if you see the cutting application in general, only 20% of all cutting is being done by lasers today, and and still 50% of that is based on CO2. But that's the area where fiber lasers, you know, the fiber laser is kind of moving in very, very fast. High power fiber lasers, because replacing CO2 lasers because of higher power, higher brightness, and especially higher efficiency, and much lower footprint, and you know, higher and better beam guide flexibility in terms of beam guidings and stuff. But that's where we think the direct diode lasers will have their main space, as direct diode could become a even more efficient, lower footprint, smaller footprint, so that means higher compact, and probably even lower cost going forward. So what, you know, touching on the macro material processing field, the big hype in this area right now is fiber lasers. Over the last 5 years, the fiber laser gained a lot of momentum, took over a big part of CO2 laser-based applications like cutting, but also welding. And it's because of the flexibility and the efficiency. It's the fiber laser kind of generate, you know, take over market from application from kind of you know, or technologies that are formerly not used fiber lasers. The thing is, the dilemma, which is a, you know, very special kind of singulated issue here in this field, is there's one company, you know, kind of owning 80% of at least 80% of this market, because they were very successfully in turning the fiber laser from telecom, you know, kind of focus into material processing. They are able to they were able to build the technology based on fiber technology that has been developed over decades, over more than a decade in the former Soviet Union, and with their unmatched cost structure, this company is kind of the leading, you know, company in this area. But it's only one shop to go, and the question is, what could be, you know, how we could, you know, the question is does the customer like the fact that there is only one, you know, supplier in this field? So the problem here for anyone else who wants to go into this technology is the problematic supply chain. All components being used in fiber lasers are more or less kind of built or handmade by you know, by very small companies, and you know, you cannot go out and buy components and build the same kind of, or another you know, a better technology here, or better product here. So it's hard for other companies like Trumpf and Rofin and other industrial companies using developing fiber lasers to generate products or develop products with the same cost structure as you know, the leading supplier here, and that's why, you know, it's the question is whether, you know, could be another technology or how we could collaborate in this field in order to create more market supply on the supplier side than there is today. So the outlook here, to come to my conclusion here, the outlook here, fiber lasers, especially in fiber lasers, is the laser platform that is creating the biggest. Creating the biggest market momentum right now, and in this field, there's only one company. As I said, the question is how to kind of create more market, or improve the supply chain here. But the end user at the end is not interested in what kind of laser he's using. The end user here, especially integrators, are interested in how to solve or how to create the highest value on their end. So the question is not about fiber lasers; it's about what the laser can be, how the laser can be improved, or what other laser platforms can do an even better job than fiber lasers. And there is a lot of development going on there. In the next step, photonics in general, lasers, laser delivery and laser processing will increasingly become more integrated, and as integrator customers especially, they are not only interested in how to generate the photons, but also how to guide the photons and how to do the process. So my opinion is in the future there will be more consolidation going on between fiber or between laser manufacturer and supplier on the infrastructure, photonics infrastructure side. So laser engine, there will be more kind of focus on providing the full value chain on the photonics part of a material processing machine. So platforms, especially also in macro, since a number of new technologies coming around the corner, based on fiber, based on direct diodes, but also will create different photonics features, like for example, different wavelengths. By using diodes with different wavelengths, or using diodes with different wavelengths, but also kind of do different pulsing. And do different pulsing schemes, etc. pp. So there will be there will be more platforms with different optical features around, which will create more or new applications, etc. pp. So, and then what can we do on in order to optimize or to kind of support European companies, and that is why we are here today. I think we need to continue to support next generation technologies through European programs, and we need to continue to strengthen or to support collaborations between companies in the whole value chain in different applications. And I think the European programs around are kind of forming the base for to kind of optimize the financial support for small and medium companies, as well as collaborations. Okay, thank you very much.